Welcome to the Future of Power podcast, where we explore how fault-managed power is revolutionizing energy distribution and driving a smarter, safer, and more sustainable future. As the inventors of fault-managed power, VoltServer is at the forefront of this transformation. With FMP now part of the National Electric Code, this breakthrough technology is entering the mainstream, unlocking new possibilities in power delivery. In this podcast, we bring together industry experts, innovators, and thought leaders to discuss the challenges, opportunities, and game-changing potential of FMP. Join us as we have meaningful conversations, share insights, and explore what's next in the future of power.
Hello, I'm Dave Johnson. I'm the CEO of VoltServer. I'm joined here today by our founder, Steve Eaves. Hi, Steve.
Hey, Dave.
Welcome to the future of power. So for over a century, electrical infrastructure hasn't fundamentally changed, but that's starting to shift. And today we're going to explore that change and what it means for the future of how the world delivers and uses power. Sound okay, Steve?
Sounds great.
So a little background on Steve. I've known Steve for about a dozen years. So Steve's the founder of VoltServer, and he is the inventor of a technology called fault-managed power. He is an electrical engineer. He got excited and interested in electronics in his military days where he spent some time before college. In college, he further developed that interest. Ended up working at some smaller companies, but early on also a couple of bigger companies, including Kimberly-Clark and Electric Boat. He developed an interest in energy control, storage, and power conversion. And then he started specifically looking at ways he might charge electric vehicles, do some charging over the roads. And if you were going to do that, it had to be safe. This was in the mid-90s or so. And this was sort of the beginnings of digital or FMP, fault-managed power, and VoltServer.
So Dave, as you mentioned, we've known each other for a while, and I think it's kind of fun that, over the last years, you've been with Schneider, and you started out as, in the early days, with American Power Conversion that was acquired by Schneider, but you actually got exposed to some early days at APC when the company was really a similar size to where we are now. I think that was a great background as a setup as our CEO, but it's also fun that, some of the growing pains that we have and some of the scaling issues that you got to see at the early days of American Power Conversion, and then you also got to be there as APC scaled with Schneider to be $1 billion+ operation. Could you talk about that a little bit?
Sure. So, right, Steve and I are sitting in an old mill building in Rhode Island, and the company is about the same size as American Power Conversion was, which was also in an old mill building in Rhode Island, around the same size. I think, and I got to watch, as you mentioned, the company grew into a multi-billion-dollar business. It got acquired by Schneider, and it's now even bigger than that. So I've got to see the things that work and don't work. I think the opportunity for our technology and how it might change the world is bigger than what I went through at American Power Conversion. So excited to jump in and see if I can help with the journey.
That's awesome.
So Steve, tell us, let's go back and listen to a little bit the story on fault-managed power. Tell us what that is, but tell us about VoltServer and how this all started and how it came from some of that early work that you were doing with trying to charge electric vehicles safely.
Yeah, as you mentioned, the early days, and this goes all the way back to the 1990s, one of my first companies was working on lithium-ion battery management systems. And back then, as many of you know, like lithium-ion batteries are the primary energy storage device for electric vehicles now. But back then, they were very early on. They were exotically expensive and volatile devices. So you couldn't use a lot of them. because you either couldn't afford them or it got too dangerous to put too many of them in the same spot. So we were trying to figure out a way to make the batteries smaller in electric vehicles, and one of the ideas was to allow the vehicle to charge as it drove down a highway or a road off the surface of the road. And to do that, you would need to expose electricity to the surface where somebody could walk on the road or touch it or whatever, or you might start a fire. So digital electricity was a way to try to make electricity inherently safe, and we accomplished that over the years. That eventually came to be known as fault managed power because the industry took note of what we were doing and started developing specialized standards. So there was a couple UL standards that were developed, and then the National Electric Code adopted the technology in 2023 as a separate section. And since then, we've been scaling a lot faster. So the generic industry name for the technology is fault managed power. But VoltServer, as the inventor, branded it very early, and we call it digital electricity. One of the most important aspects of digital electricity is that it's safe. So you can touch it with your hands or expose it to a building, and it won't hurt anybody or start anything on fire, as opposed to AC electricity, which really doesn't know the difference between burning a village down or powering a factory 50 miles away. And I should say that it's really kind of a simple concept. Rather than sending electricity continuously like water coming out of a hose, we break that up into what we call a packet. So we send a very small burst of electrical energy, and then we track it from a device called a transmitter to a receiver. And if between that space, if it goes into your body or if it's about to start a fire, we can very accurately detect that very small amounts of energy were lost in that transfer, and we can stop sending electrical energy on that channel. So we send those packets very quickly so we can achieve very high amounts of power, industrial power levels, but it really acts like very safe, low voltage electricity that would be on your USB cable. It's just very fast and easy and safe to work with. Okay, so Dave, the company is scaling now, and you're a new CEO, and your mission is to take us to the next level. So, what surprised you about VoltServer and digital electricity when you first heard about it?
Well, the short answer is I was surprised it wasn't everywhere yet. When you and I met all those years ago, I thought it had so much potential, it was so interesting. So that would be my short answer. Is I thought it would be in more applications, in more places, in more types of applications.
Yeah, that makes sense. That makes sense, and it has taken a while for reasons that we've talked about. When you see us going into the future, where are some of the application areas you think we'll be focused on?
So right now, from what I see, the technology is mainly used in telecommunications applications, specifically antenna and radios. That powering antennas and radios is part of cellular and communication networks. And interesting, when I came in, my one observation is we hired some people in that space, and guess where they focused in the telecommunication space. So they've been very successful there. But what I can see as the company has tried to do other things is I'm looking for signals coming back. So where else is it sort of naturally getting picked up? And I see a lot of interest in very similar types of parallel applications in IT. So think IT networking instead of telco networking. If you look at the way networks are deployed, they're in difficult to reach places, they're spread out over long distances. Applications like a big distribution center where there are big network switches, big network closets over long distances. Certainly any place where there's a need to run power outdoors somewhere. This is where we've been successful in telecommunications. I can see a clear path to do the same thing in IT. Now, going a little farther into IT, of course, we have to talk about data centers. There's a lot of attention on data centers right now. after spending some time with you just before I joined and just after, we see a lot of opportunity in data centers. I'm going to come back and ask you about that in a minute, but I come most recently from the data center world, from my work background, and I see a big potential there. There are big challenges there. The traditional ways of distributing power with AI and the servers and the power requirements that are showing up for those applications, they don't have all the answers. I think we can help. And what a win for the data center industry and for digital electricity if we can be successful there. Finally, an area you're working on is electrification of buildings that we all spend time in. In particular, you're looking at things like the electric heat and electric cookware, or electric cooking, and powering those types of heating, cooling, and cooking devices now in old buildings is turning out to be a challenge. So those are things I know you're looking at. Those are the things that I would see over the short term. But why isn't, if it's such a compelling approach, why isn't fault managed power everywhere?
I think the main reason is that electrical infrastructure takes a long time to change. The world has evolved around AC infrastructure, and devices have adopted it. Whether it's your television set or a computer, the inputs to those devices are using AC power. The surprising thing, though, is that inside the devices, after the AC power gets through the sheet metal or plastic, they've quietly adopted DC power inside. And so if you look at a refrigerator or your heat pump at home, that device is converting AC power to DC and operating on DC because that's the most efficient way to operate the appliance. I think that is a reason why things will move a little bit quicker than people might expect of converting over to fault managed power.
So if you've talked about digitization and maybe that's the catalyst to drive some real change now, combine that with what you just covered, you're starting to see DC in devices and smart connected devices. Where could power distribution be in 20 years?
I think in 20 years, buildings will, in an ordinary way, be specified with DC power as a primary driver. And more specifically, I think that DC power format will be fault managed power because of the safety, controllability, and compatibility with data that fault managed power has.
So paint us a picture. Give us some examples of where we might see really specific use cases and where we might see power distribution done with digital electricity.
I believe things will start inside of buildings and kind of work their way out. The things like the transmission lines overhead and grid distribution will take a little bit while longer, but inside of buildings and devices themselves, I think will convert a lot quicker. So as I mentioned, like when architects specify a building distribution system 20 years from now, it will often be specified with fault managed power by that time.
And if I'm so I'm 20 years out, am I going to still see the normal AC 15 amp outlets I'm used to plug in my hair dryer? I don't really use a hair dryer, but something like that.
I think it's going to take a while for those outlets that you see in your home to convert because there'll be a lot of legacy devices that are hanging on. But if you think about it, the inside of a hotel room or even your own home, there's very little things that are actually using AC power for real inside. As I mentioned, you're in induction range. LED lights are DC based. Inside the induction range, it's DC. Your refrigerator is DC inside now because they're high efficiency devices. All those things are changing very quickly. But but there'll always be a few devices that are hanging on. The difference will be that the primary distribution for the building will be DC power, and then for the little bit of AC power that remains, that converters will convert that over. Kind of like with your computer now, you have converters that convert USB to some other format and vice versa as a separate box. I think that's the way the AC outlets will be handled by that time.
Okay, so that's how, what I'm used to today, how I'll manage that. I can get a picture of that. Is there any other change I would see in a building or a home or a data center? Well, we'll park data centers again for a minute, but would the experience be any different as a user in a hotel, in an office building, in a house?
Yeah, I think we talked about digitization, and by that time, I can't even imagine what a home will be like. If you see what's going on now with home management, like smart home management, and the convergence of AI and digitization with all of that, things will be highly digitized. So in a home, when you walk in, the home will know a lot of things about your life and operate automatically and interact with the users that are in that home. And those devices will be connected digital devices.
So digital electricity then makes a ton of sense in those environments.
Absolutely. Digital electricity, because of its natural compatibility with data and its safety characteristics, is the right thing to use for those future homes and venues.
So if I turn this back to you for a minute, Steve, so let's talk about data centers for a minute. What do you see in data centers from a power architecture standpoint, and how can VoltServer help?
Well, that's a really good example of how the world is changing. So you could see when we talk about the convergence of DC power devices and digitization. For example, AI data centers are one of the primary examples of that. People thought that industry was a bit slow moving 10 years ago, but with the advent of AI, they're looking at all sorts of different ways to try to manage the power demands of these processors that are processing AI models. So that already in data centers, they're converting over to a DC infrastructure within the data center. And that DC infrastructure is brand new to a lot of folks that are operating data centers, and also to the trades that need to put them together. And so there, digital electricity has a great advantage in terms of being something that people can work with safely and quickly, and it's even denser than the DC infrastructure approaches that people are proposing out there right now.
Right. So even the architectures that the industry is proposing, they don't have all the pieces yet. They're trying to get all the players to do their piece. But the one way they're trying to do it with traditional approaches, they don't have all the answers yet, do they?
No, they don't. And if you think about what's really trying to be accomplished in the data center, is that there's a bunch of processing units that need to be placed very close together because they're all communicating with each other and operating in parallel. And there's a big drive to get those communication links as short as possible so you could reduce the delay in that communication. And so that means that folks don't want a lot of other stuff inside that computer room than the computers themselves. And the electrical infrastructure today, because it isn't inherently safe like digital electricity, requires a lot of stuff around it to keep people and buildings safe from it. And using digital electricity, you can really reduce the space that takes up because you don't have all that external equipment protecting people and building components because it's inherently safe from the start. So I think that's going to be a big advantage in terms of the thing that people are really trying to accomplish, which is to reduce the size and space that's taken up by electrical infrastructure.
So as I've started here over the last couple of months with VoltServer, I've spent some time exploring the data center opportunity, and between some of the big power vendors, power equipment vendors, the customers and the third parties that sit in between them, there's a lot of interest in what we're doing. So I'm really hopeful and excited about working on the data center market. If we look back at this, when we both feel pretty strongly that now is the time for fault managed power and digital electricity, there are some signals. You talked about digitization being a catalyst for making this our time now. There was a recent survey done by Electri, a Blue Ocean survey on the technologies that really are poised to make a difference in the electrical world. Tell us about that.
Yeah, so a Blue Ocean study is, let's call it an opportunity base for folks in the future. So the Electri is the research organization that is attached to the National Electrical Contractors Association, so the unionized electricians in the United States. And so they looked at 34 different technology areas that included things like microgrids and small modular reactors and DC power itself, or conventional DC power in data centers. And out of those 34 different technology areas, fault managed power selected as the top Blue Ocean category for electrical contractors in the future. Why is that? It's not as we said, it's still emerging as a technology, but they identified the technology as something that's ready or mature for use, but also something that is quickly moving, and more importantly, something that the electrical contractors are trained up and that they can execute on quickly. So they saw that as the top emerging Blue Ocean category. So Dave, beyond the applications that we talked about, where do you see VoltServer going farther in the future? What's your vision for the company?
So I think for VoltServer, for fault managed power, for digital electricity, again, we're on the cusp of a big change in the industry. So for us, I think it's our mission to fundamentally change the way the world delivers and uses power. I think it's that big.
Yeah, I see that too.
So how about you, Steve? Do you have a final closing thought on the future of power?
Yeah, I usually like to baseline things when we talk about this technology. If you think about what is digital electricity? Digital electricity is a format of electricity that is safe to touch, that doesn't start buildings on fire, and coexists seamlessly with data. So we really see digital electricity as a third format of electricity that over time will replace conventional forms like AC power that we see today.
So we've had AC, we've had traditional DC, and now we have digital electricity.
Yeah, that's right. That's how I see it.
Well, Steve, it's been a pleasure speaking with you today and talking about digital electricity. I hope you've had a good time too.
Yeah, same here, David. I'm looking forward to working with you and seeing where you're going to take the company.
And this has been the future of power.
Thanks, everybody.